one of the world's many building blocks. What's more important than carbon is more carbon. Carbon to make more carbon allotropes. Two-dimensional carbon. These three allotropes of carbon, spherical buckyball, 1D nanotube, 3D graphite, are really all derived from a layer of carbon sphere rolled into a tube or layered for graphite. Although these were all developed and known before graphene was technically discovered, they were still the underlying building block. So Novoselov and the other guy, I can't remember how to pronounce his name very well. Yeah. And graphene was born. Graphene. Why is it so useful? In essence, it's because of the way these carbon atoms are bonded, they leave a free electron for each atom to roam around as they please, yielding really high electron mobility, high conductivity, ions for high thermal conductivity, and the list goes on. Even better, its mechanical strength is so strong that pound for pound, or micropound for micropound, because it would be really hard to get a pound of graphene, it is about, was it 100? Yeah, 100 times stronger than steel. Cool thing, if you look up the Nobel Prize, I guess the laureate, whatever, the summary, if you put a 4-kilogram cat and a blanket of it, of graphene, 1 meter squared, it would hold up a 10-pound cat. Which is pretty amazing considering they said that would be an estimated 0.77 milligrams, which would be about the weight of the cat whisker. Now the only issue is, the reason it's so inherently specifically strong and it's got these nice properties is because of its one atomic layer. So building it up into a large form kind of takes away from that purpose, hence putting it into composites, nanocomposites, because it is a nanomaterial. Now what is a composite? Composite is simply just a combination of two materials into one to yield beneficial properties from both. And so the same goes for nanocomposites. Now, the biggest ones, ceramics, polymers. There's other ones as well, but those are the main categories. Now, nanocomposites obviously weren't an original thing with just graphene. It's something that's been around using nanomaterials and their beneficial properties to realize large-scale things. Graphene has been shown to be a better carbon filler than others, such as carbon nanotubes. Carbon nanotubes are great. One is they're actually pretty expensive to still produce, even though they've been around for quite some time. And they've also noted that the dispersion of the carbon nanotubes in the ceramic polymer matrices is still very difficult. Hence, the next logical step is using graphene. So with ceramics, it was seen with, I believe, alumina, just loadings of 3 to 15%. They went from conductivities, electrical conductivities of nearly 0 to about 5,500. Now, to put that into perspective, they estimate graphene about 1 million Siemens per meter or inverse ohm meter. And so you can see that, with just loading still a sixth of total weight, you can still get high electrical properties. Another thing that was seen that was really awesome was mechanical, I think it was still in aluminum, mechanical properties, Young's modulus, tensile strength, compressive strength. With graphene as a filler as opposed to carbon nanotubes, 10 to 15% increases across the board were seen with the same weight percent loading. So that showed that graphene was indeed a more beneficial mechanical loader than carbon nanotubes.
So let's just piggybacking on what Taylor said earlier and trying to elaborate further on why graphene is important. We already know it's got this wonderful properties. He was talking about the strength and all that, but where does this all come from? Graphene has properties like its electrical conductivity, it's got its mechanical properties, its optical properties, thermal properties, and magnetic properties. Due to time constraint, I can't actually go into so much details, but I'm talking about electrical conductivity in terms of going to be a lot better than conventional materials. Its mechanical properties in form of strength, which, as Taylor said earlier, it's a thin film of graphene is a lot stronger, head-on structure that's a lot thicker. Now with optical properties, which which we can look at in terms of its light absorption and refraction rate. Graphene seems to absorb light about 2.3%, which is really good. Its thermal properties can be looked at in terms of its insulation, which again comes into particular use for power building materials and movements at certain circumstances. It does have magnetic properties for thermal shielding. This could be looked at in form of MRI. Why are they significant? Why do we want to consider these properties? Why do we want to look at them? We need to understand that these properties can be transformed into applications. Such applications are referred to in terms of its fuel electric transistors. This is a direct correlation to its electrical use, where we can talk about it being used in such devices like OLED TVs right now, mobile phones. Graphene has made it possible to basically make devices smaller, stronger, better. We're talking about energy storage. This could be in form of its either mechanical properties or electrical properties as well. But in terms of energy storage, we're talking about things like photovoltaic cells, lithium-ion batteries. These are larger capacity, they charge a lot faster. This has actually changed the way batteries are now viewed, or batteries are now created, or basically importantly. And what I want to talk about in terms of its application functions will be its ultrafiltration applications. This can reduce or eliminate our dependence on biofuels as humans, which obviously has a dominant effect on the economy, or rather on the atmosphere itself. It's due to the fact that graphene is impervious to liquids and gases. This makes it a unique device for ultrafiltration, where we can actually have better desalination processes, reduce the energy being used, and have better producing devices. We hope we've been able to pick some interest into what the uses of graphene can be, the larger picture of how it can be incorporated, the applications that make it worthy of research, interest, and funding, and also the functions where it's being deployed right now. It is noteworthy to mention there are still some shortcomings. Even though it has all these wonderful properties and applications that are being deployed, there is still the challenge of actually incorporating them into everyday devices on a regular basis. That seems to be a focus where research is going, finding out new ways to actually incorporate graphene into our everyday lives. I hope Taylor and myself have been able to show you a little bit of what this paper was about, or what Graphene Nanocomposite has in store for the future.